All right, so this week we're going to take a look at section 2.2. It's on what we call a unit circle trig. We'll do the whole week pretty much on just this one section, 2.2. And then on Thursday, the plan is to do a review day. Okay. So I'm going to start out with looking at this diagram. Okay, so that diagram basically just a circle with an XY axis through it. And because we're studying what's called unit circle trig, unit means one. Okay, so a unit circle, and I think I mentioned this last week, it's just a circle with a radius of 1. And that's what I have up on the board. We can mark the degrees, different angles as we go around the circle. So 0 degrees is always on the right-hand side, 90 at the top, 180 on the left, 270 on the bottom. Now, we can take and put a point anywhere we want on that circle. Okay, let's just put a point right about there. That point represents an angle. How much of an angle? Well, you have to kind of go like this. I tried to estimate it to be about 45 degrees, rotated counterclockwise from the horizontal axis. I don't really care what the angle is. Okay, well, it's an angle. Whatever it is, it is. What I care more about is this. Once you know what kind of angle you have, you're going to have a point somewhere along the edge of the circle that represents that angle. That point is going to have a coordinate. That's the whole goal of unit circle trig. To find a coordinate that connects to a certain angle. Now, some angles, it's easy to find the coordinates for. We're gonna do 4 angles right now. So we're gonna do 0, 90, 180, and 270, and see if we can get those. Now remember, this circle has a radius of 1, which means this is that's your origin right there. So that's 0, 0, where I just clicked. So anyone think they could tell me what the coordinate of 0 degrees would be? Keeping in mind, you haven't really gone up and down there. All you've done is go to the right, and you're on the edge of the circle, and we know how big the circle is. Yep, Jess?
0, 1, or 1, 0.
That's going to be 1, 0. Yep. So on a unit circle, the coordinate that represents 0 degrees is 1, 0. All right, now let's find the coordinate for 90. Okay, someone else think they could tell me the coordinate for 90 degrees? Don?
190.
Can you say it again?
190.
So you're saying go right 1 and then up 90 units?
Oh, you mean like normal, not unit circle things. Okay.
Unit circle. So we want the coordinate for 90 degrees on the unit circle.
190 degrees.
So 190 means you go right 1 and then go up 90. Would that put me right here?
No, but
If I went up 90, I'd be up very, very high. Anyone have another guess? Yep, 80. So 1, 1 would put you right 1, up 1. Put you about right there. Pete?
0, 1?
Yes, 0, 1. So the coordinate for 90 degrees is 0, 1. 90 degrees is right here. There's no movement left or right to get to 90 degrees. So that's 0. But you've gone up 1, because you're right on the edge of the circle. Okay, so 0, 1. How about 180? What would be my coordinate for 180? Yeah, Angelina? Yep, that would be negative 1, 0. And the coordinate for 270, you don't go left and right, you just go down 1. is 0, -1. And those 4 coordinates never change for the whole week. Those are always going to be the coordinates that represent those 4 angles. So the important thing here is each coordinate has 2 numbers. What do you call the first number? Or what does it represent? It's your what?
X.
Yep, that's your x. And the second number is your y. So you could name any angle you want, right? We did 0, 90, 180, and 270 because those are the easiest. But we could pick any angle we want, put a point on the circle, and find the coordinates for that point. And that's what we have to do pretty much the whole week. Find the coordinates for a point. And that's the idea of unit circle trig. Any question on the idea of what we have to find? Now some angles are harder to find. Like 45s we can do. Multiples of 30 we can do. But some angles, like if you said, well, what's the coordinate for 10 degrees? That's a hard one. So there are going to be certain angles that we don't use this method for. Okay, but angles that are multiples of 30 or 45 are going to work perfect on this. Okay, and those are the ones we're going to focus on. Yeah, Don?
Yeah.
All right. So basically what I just explained to you. Every angle on the circle can be represented as a coordinate. And again, even though we could do every angle, we're not. We're going to stick to certain angles, 30s and 45s, multiples. Now, there's 2 directions we can move around the unit circle. We can move clockwise and counterclockwise. Does anyone remember from last week which direction is positive? Yeah, Colby?
Counterclockwise.
Yes. If you move in a counterclockwise direction on the circle, it's positive. If you go in a clockwise direction, it is negative. Now, if we had a choice between working with positive or negative angles, what do you think we would pick? If we could choose between positives and negatives, which ones do you think would be easier? No?
Depends if you're drawing it out or doing the numbers. If you're doing the numbers, you would want to go with positive, but if you're drawing it out, you would want to go with negative.
Yeah, most of the time we're gonna be kind of figuring out like what the numbers are. So we're gonna want to try to stick with positive angles. It's gonna be easier to think about for what we're doing. Alright, so what we're looking at here is a circle. This is not necessarily a unit circle, but I'm just trying to show you the direction again. If you go in a counterclockwise, it's positive. You go clockwise, the angle's negative. And you're going to notice that as we do that, all of a sudden certain angles have like a pi in it. When I get it right on 30, it says pi over 6. Or if I put it up to 45, it says pi over 4. So this calculator is kind of doing the same thing we're going to do. It does something special for angles that are multiples of 30 and 45, which is exactly the ones that we're going to be focusing on up until Wednesday. Now, the top number is degrees. Does anybody remember what that bottom number is? Angelina? It's radians. Yeah, very good. So that's radians. So we're going to be given angles sometimes that are bigger than we want, okay, too big to think about, or we might be given an angle that's negative, and we said earlier we don't really want to work with negatives either. We kind of want to have every angle that we want to work with between 0 and 360. Okay, that's pretty much what we're trying to focus on. So let's look at an angle that's too big. Let me bring this back up. There's an angle you might have to work with, 450 degrees. what you're going to have to figure out, and it's probably easy, a little easier because you have a picture right now, but if I gave you 450 degrees, your first step is to find the coordinate for 450 degrees. Well, 450 degrees is the same as something else. Does anybody see what angle is the same as 450? 80? 90. 450 and 90 land in the exact same spot on this unit circle. So what's the pattern there? Does anybody see what you can do to the number 450 to turn it into the number 90? Yep.
Subtract 360.
Yeah, you can subtract 360. And what's special about 360 degrees? What do we call 360 degrees? It's a, yeah, it's a circle which is one revolution, right? One revolution. Anytime you're on a circle and you go around exactly one time, you end up right back where you started. So if you're here and you subtract one revolution, you end up exactly back at the same spot, but now you have a smaller angle. So if you have an angle that's too big, we can subtract 360 as many times as you want, and it'll keep bringing you back to the same spot. But we don't want to keep subtracting 360 forever. We want to stop at one point. You want to stop before you get negative. If you subtract 360 too many times, it's going to go negative. So always want your angle between 0 and 360. And at least for me, it's easier for me to think about what a 90-degree angle looks like versus 450. Even though they're the same thing. Right? But 90 is just easier to think about because it's smaller. All right. Now, what if I had something like this? Let's say you had to work with this angle. Negative 540. Right? Some people it might be kind of hard to think about. They might not know that it lands right there. What do you think you can do to an angle that's negative to make it positive? Pete? Yeah, add how much?
360.
Yeah, we can add 360. Okay. So if I add 360 one time, I'm at negative 180. All right, so that's better, but still not where I want it. So what could I do now? Yep, Jess?
You add 360.
I just add 360 again. There we go. Nice easy angle to think about now, 180 degrees. So negative 540 is exactly the same as 180. But 180 is easier to think about because it's smaller. So if you have an angle that's negative and you want to make it positive, you can add 360 degrees as many times as you need to. And it always brings you right back to the exact same spot in the circle. Because what we don't care about with unit circle trig at all is how many times you go around the circle. That means absolutely nothing. All we care about is where did you stop on the circle. And we need a coordinate. Alright, so what we're going to do now is we're going to look at what's called the six trig functions. Okay, these are kind of the most important functions that we use in the entire class, okay, for the whole class. And the way we're going to define these functions is based off this. It's all going to be based off knowing a coordinate. A coordinate has an x value and a y value. So, that's what I just said. So when you're doing unit circle trig, if you can't figure out the coordinate, you're not going to be able to do any of this. You have to be able to figure out a coordinate. All right, does anybody know some of the trig functions? There's 6 of them. Probably studied them in geometry or algebra 2, but just, you know, one of them?
Isn't it like the cosine?
Cosine is one, yep. Anyone know another one? Tom?
Sine.
Sine? Yeah, those are the two most basic ones we use. Sine and cosine. We have a third one here, tangent. And I'm going to show you what the formula is. Now remember, this formula is based off of a coordinate. So, if you have a coordinate that represents some angle, and they ask you about the sine, what they're asking you for is the y value of the coordinate. You don't need the x, not for sine. Okay, if they want to know the cosine, once you find the coordinate, you would write down the x value. And for the tangent, you need both. You need y over x. So you take your coordinate, take the y value, divide by the x value, that's tangent. Now, these other three trig functions are not used as much, but I wrote them in two columns on purpose because there's a connection between the one across from it in the same row. Let me show you what the cosecant is. So the cosecant is 1 divided by y. Anybody see the connection between the cosecant and the sine? Yeah, Colby?
It's the reciprocal.
Exactly, perfect. It's the reciprocal. The simple word is it's flipped. And if you're like, wait, how do you flip something that's not a fraction? Well, just pretend that's a fraction and put it over 1. So it becomes 1 over y. All right, so based on that, how about Mateo, what do you think the secant is?
Probably 1 over x.
Yep, good. It's going to be 1 over x. The secant is what we call the reciprocal of cosine. It's the cosine flipped. And how about the cotangent? Oh, Jacob, what do you think the cotangent is going to be?
X over y.
Yep, cotangent is going to be x over y. So those are our 6 formulas, all based off of a coordinate. Now, if you learn this as like opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, some of that sounds familiar, same thing. It's just a different way of thinking about it. We're going to do the opposite, adjacent, and hypotenuse stuff next week. But this is exactly the same thing. Yeah?
Shouldn't cosecant cotangent be switched?
Cosecant and cotangent. Why?
So I thought it went in the order of the names, like the co of each thing came after it.
No, that's a different relationship.
Okay.
So if you notice here, we're not going to talk about this too much, but since it just got brought up, there's 3 trig functions here that have the word co in front of them, and there's 3 that don't. If you pair up sine with cosine, that's a different connection. But these 2 are connected to each other. Just look at the spelling. One has co in front of it, one doesn't. That means something. But we'll talk about what are called co-functions probably next week. Okay, questions on those 6 definitions? All right. So the 4 angles that we talked about so far that you know the coordinates for are 0, 90, 180, and 270. Since those angles are right on the axes, and the axes divide things into quadrants, we call those angles the quadrantal angles. That's just a special name for the group of 4 angles. now we'll kind of just put it all together. So, to do unit circle trig, there's 2 steps. All right, so what a question might look like is something like this. They'll give you a coordinate, and they're going to ask you to find the 6 trig functions of that coordinate. That's one way they could give you the problem. Or, they could give you a problem like this. Find the 6 trig functions of 90 degrees. This time, you're missing the coordinate. Whenever you don't have a coordinate, what do you think the first thing you're going to have to do is to do unit circle trig? Yep.
Find the coordinate.
Find the coordinate. So step 1 is always to find the point on the circle that represents the angle. Find the coordinate. It says in parentheses, sometimes you'll be given the coordinate. Sometimes you will, sometimes you won't. Depends on the problem. So locate the coordinate on the unit circle that represents your angle. Now, once you have the coordinate, step 2 is to fill the coordinate into one of these 6 formulas, or all of them, depending on what they're asking. So you have to now use the formulas from that page right here. Step 2, use the coordinate from step 1 and the definitions that I just gave you to find what they want you to find. In class and on the homework, we're going to practice all 6. The sine, the cosine, the tangent, the secant, the cosecant, and the cotangent. But on the test, you will have a problem that, for example, it might just say find the cosine. And that's it. Just find that 1 out of the 6. You don't have to do all 6, just 1 out of the 6. Then another problem on the test may say find the tangent. Another one might say find the secant. That's what we'll do for the rest of now. We'll just try some examples, and that'll be it. Okay, everybody have steps 1 and 2. So, before we even do anything, let's just look at that coordinate for a second. So look at those numbers. P just stands for point. So my point is -1/2, comma, square root 3 over 2. So if you look at that coordinate, does that look anything like the 4 coordinates that we wrote down earlier for 0, 90, 180, or 270? Is it one of those 4? How about Raymond?
It's not at 180.
One.
-1.
It's -1, 0?
Yeah.
So that point in that example said -1, 0?
Yeah.
So that one says -1, 0?
Oh, no.
No. So let's look at it again. Does it match up with any of those 4? 0, 90, 180, or 270? How about Cassie? What do you think? No. It doesn't match up with one of those 4, which means it's not the coordinate for 0, 90, 180, or 270. What is it the coordinate for? Don't worry about it. It doesn't matter. You don't need to know what it's for. It's for something. But the important thing is that you have the coordinate. You don't need to know what angle it represents. And at first, some people get confused with that. They're like, well, if we don't even know what angle this represents, how can we do anything with it? Well, how can I describe what you're wearing without knowing your name? That's not that hard. I don't need to know your name to describe what you're wearing. You don't need to know what this angle is to do some work with it. The important thing is you can see the coordinate. That's all you need to see. So it says, let that point be a point on the unit circle that corresponds to an angle. What angle? Don't worry about it. Just represents some angle. We want to find the 6 trig functions. And since every formula is based off knowing x and y, that's all we need. Now, a few things are going to come up when we do this, and we practiced this last week. I asked somebody earlier what the connection was between two things, and they said, well, one of them is a reciprocal. Reciprocal means to flip. If you notice here, there's something that if you flip it, it's going to be a problem. We're not allowed to leave certain things in the denominator. So if that ever comes out, we're going to have to fix it. Okay. So if you're not sure what I'm talking about, you'll see very shortly. But that's going to tie in with some of the stuff we did last week. Did you have a question?
Yeah, I was gonna ask, like, what would happen if we flipped it? Are we allowed to do that for the square? That was all.
So you have to flip, you're going to have to flip everything if you're doing all 6. Eventually you're going to have to flip the x and the y. And there's a certain thing here, if you flip it, it is a problem, but we'll have to fix it. All right, let's start with the sine. Ben, what was the formula we had for sine?
Equals what?
Yep, sine is the y value. Frankie, what's my y value in this problem? Yep, what is it? You don't have to change it to a decimal or anything. I just want to know, like, so I have 2 choices here. I just want you to tell me which one is the y.
Oh, the 3 is square root of 2.
The square root of 3 over 2. That is my y value. Sine is equal to y. That's all I have to do to write the sine and get the answer. It's just square root 3 over 2. We're not going to be worrying about decimals for most of this. Don, what about my formula for cosine?
X.
X. Right, so Raymond, what's my x here?
-1 over 2.
Good, -1 over 2. And there's my cosine. Okay. James, what's my formula for tangent?
For what?
For tangent. You want to help him out? You don't have to tell me in this particular problem. I just want the general formula. Yeah, Pete?
Y over X.
Y over X.
Which is, y.
All right, so we got Y over X. So we're going to look at Y over X. 3 over 2 divided by -1/2. 3 over 2. You know what? Let's fill more space. So that's y over x. Okay, so this is one thing we have to fix. You don't want to leave an answer as a fraction over a fraction. So how do we divide 2 fractions? What do we do? Yep.
You multiply them.
Okay, so can you explain to me how to change that into multiplication?
Isn't the first one the reciprocal? Or about the second one?
The second one.
Oh, okay. So the first one stays the same.
Okay, so we can keep that the same.
The second one will be 2 over -1.
Yep, and it doesn't matter where you put the negative, as long as we keep the negative there somewhere. And then when you multiply these fractions straight across, Colby, what's gonna happen here?
The 2's cancel out.
Yeah, we did a ton of that last week. You get the same thing in the top and the bottom, the 2's cancel out. Now, instead of going through that, which is perfectly fine, you keep the top the same, change the multiplication, flip the one in the bottom. When I see two fractions with the same denominator, I just cross the denominators out like that, because I know they're going to cancel out anyway. So all I'm left with is square root of 3 divided by a negative 1. Okay, well, positive divided by negative is negative. And if I just have a denominator of 1, I don't have to put that. And that's my final answer. Any question on how we got that? Okay, well, let's do the last three. Lacey, what's my formula for cosecant?
1 over y.
1 over y, which somebody said earlier just means flip, take the reciprocal. So take the number that's right here, this is y, and if you do 1 over something, all it does is take that fraction and flip it. So we're going to start with this. That's 1 over y, reciprocal. Now, how about Autumn, what's wrong with the cosecant?
A square root is not allowed to be in the denominator.
Yeah, we don't want to leave the square root in the denominator. So Jess, how do we fix having a square root in the bottom?
Would you multiply?
So we're going to multiply. And what do you multiply the top and the bottom by?
Just multiply by 3.
Multiply, can you say it again? Multiply by?
By 3.
So we want to multiply top and bottom by square root of 3. Okay, so this is what we had to do last week. Well, actually we didn't do a ton of this last week, but we talked about square roots. In multiplying the top, you have 2 square roots of 3. And in the bottom, what's the square root of 3 times the square root of 3? 3. So square root of 9, which is just 3. And that would be the answer for the cosecant. All right, let's take a look at the secant. Jaden, what was my formula for secant?
I think it's x over 1.
So x over 1 is, or
1
x
over
is my cosine.
1 over
1 over x. Yep. Which means just take the x value, flip it. That's what 1 over means. So if we flip negative a half, how about Ava, what do I get when I flip negative a half? So we want to take the reciprocal of this number. Not sure. You can help her out. What's the reciprocal of negative 1/2? John?
-2.
Negative 2. Should be negative 2. Questions on that one? That one wasn't anything we have to worry about cleaning up because there's no square roots. So that part's not an issue. All right. And my cotangent. Vivian, what's my formula for cotangent?
X over y.
X over y. And what's the connection between cotangent and tangent?
It's a reciprocal.
It's the reciprocal. That's what you want to keep in mind. I could go back to the original problem and do negative 1/2 over square root 3 over 2. But I've already done that for the tangent, and I simplified it by canceling some stuff out. So I'd be better off to use this simplified answer. All you have to do to get the cotangent is take the tangent and flip it. If you want to think of that as a fraction, it's negative square root 3 over 1. Flip it. Negative 1 over square root of 3. It's exactly the same as going all the way back to the original problem and doing x over y, but I already know the 2's are going to cancel out. All right, so I got that. And what do I have to do to fix that?
Find a way to get rid of the negative.
We don't have to get rid of the negative. Negative is okay. What's not okay?
The square root.
The square root, right. The square root's not okay. How did we fix the square root when we had that problem before?
Cross multiply.
Think back to the top one on the right-hand column, the cosecant.
Multiply by itself.
All right, so we multiplied, I like that. We multiplied, and what would go in the top?
The same root or square root of 3.
Square root of 3, and what would go in the bottom?
Square root of 3.
Square root of 3. Okay, and when we do that, we're going to get negative square root of 3 in the top. And square root of 3 times square root of 3 is square root of 9, which is 3. Now, we said last week, if you've got the same number in the top and the bottom, you can cancel it. Can I cross the 3's out? In that case?
No.
No. That 3 is under a square root. Okay, so don't ever try to cancel that out. You can't do that. Okay? So this kind of problem, this would be 6 different questions on the test. Each one of those things I have circled would be its own question. Anything on these first 6 answers we got that anyone would like me to go over? All right, let's try this one. So same kind of setup. Find the 6 trig functions. And again, you're giving me a coordinate. Now, that last coordinate was kind of a weird one. It had a root 3 over 2 and a 1/2 in it. This coordinate is root 2 over 2, comma, root 2 over 2. So this represents a point on the circle in quadrant 1, because it's positive, positive, but the x and the y are the same. You don't have to know this for the problem, but does anybody have a guess what angle that's the coordinate for? JD? Exactly, it is. That is the coordinate for a 45-degree angle. Again, you do not have to know that to do this problem. You will have to know that tomorrow. But for today, we have an x value, we have a y value. All we have to do is fill them into formulas. We don't have to worry about anything else. And because the x and the y value are the same, we're going to get a lot of answers that are repeated. So let's start with sum. Olivia, what's my sine here? Exactly, and can you tell me which one, since they're the same this time? The y. Yes, the one on the right. Square root 2 over 2. All right. Aiden, how about my cosine? Okay, so Aiden, how about my cosine?
Cosine would be square root of 2 over 2.
It's also square root of 2 over 2, but this time it's the x. If you mix them up this time, it wouldn't matter, but most of the time it does matter, so we don't want to mix them up. Okay, and my tangent. Now, we really don't have to think of it as y over x. Well, I mean, we want to think of it as y over x, but y and x are the same. So when you divide two things that are the same, we don't really have to go through all the work. What do you always get when you divide two things that are the same, then? 1. Right? And while we're here, just because it's the easiest one to do, my tangent is 1. What's my cotangent going to be? 8?
1.
1. Because remember, to get the cotangent, you take the number for tangent and flip it. Well, 1, when you flip it, stays the same. There's only 2 numbers you can flip, and they stay the same. This is one of them. 1. There's one other one. We'll see if it comes up at some point. All right, and now my cosecant. All right. So Sean, once I have my sine, what do I do to get my cosecant? So what have we been saying the connection is between the one that's across from it? Some people use like a fancy word that begins with an R. Sometimes I use a simpler word to explain it. Sure, anyone help them out? What is it, Vivian?
It's 1 over square root of 2.
Which is the,
Reciprocal.
it's the reciprocal. We want to take what we have here and flip it. Okay. So let's start with that. Okay, so that's step 1. As far as the trig goes, we're done. It's just arithmetic-wise, we don't want to leave it like that. James, how come I don't want to leave it like that?
Because you have a square root on the bottom.
Okay, and how do I fix that?
You multiply the top and the bottom by square root of 2.
Exactly. Multiply the top and the bottom by square root of 2. In the top, you just go straight across, 2 root 2. In the bottom, the square root of 2 times the square root of 2 is how much?
2.
2. And now you can cancel out 2. You have a 2 on the outside, not under a root. You have a 2 in the bottom, not under a root. So those 2's end up canceling out, and the final answer is just square root of 2. How about my secant? What's that going to be? Yeah,
They're the same thing.
it's the same thing. Sine and cosine are the same number. So it doesn't make sense to go through all the work of flipping this again. You just did it. So those are the 6 trig functions for the coordinate square root 2 over 2, comma square root 2 over 2. And technically you could say those are the 6 trig functions for a 45-degree angle. We're going to tie that piece in tomorrow. Yeah, any questions on that one? All right, so I think we've done a good amount with these. This would be kind of the same thing again. You've got your x, you've got your y, and you go through it just like the last 2. Let's try something different. Find the 6 trig functions for 90 degrees. Okay. I already hinted at it earlier, but what's different in this problem? You're not ready to do unit circle trig in this problem yet. Okay, think about what do we need to know for every unit circle trig problem we're going to do. Ben?
Well, we need to know the coordinates.
You have to know the coordinate. You either have to memorize it, or you have to have a way of figuring it out somehow. So the way you figure it out, what I usually do is just make a sketch and put 90 degrees where roughly it should go. Where's 90 degrees on the circle? On the right, top, bottom, left. Yeah,
The top.
it's at the top. What was the coordinates for a point on the top of the circle? Lacey?
0, 1.
0, 1. Now that you know the x and the y, this problem is just like the first 2 we did. You had to just figure this out first. All right, let's go through. Raymond, what's my sine?
1.
Good. 1. Okay. Colby, my cosine?
0.
0. And now my tangent, don't try to do anything fancy, let's just write it as a fraction. Jacob, what's my tangent?
0 over 1.
What's the formula for tangent again?
1 over 0.
Yeah, the formula is
Y over X.
y over x, which in this case is 1 over 0. Now I want to know what that is. 1 divided by 0. What happens if I were to type that in on a calculator? Pete?
Undefined.
Undefined. Very good. You can't do that. Whenever you have a number and you try to divide by 0, it spells no, because you cannot divide a number by 0. Okay, so undefined. All right, so we got that. So Cassidy, now that I have the 3 on the left, what am I going to do with each one of these to get the 3 on the right?
Flip them.
Flip them. If it doesn't make sense because it's not a fraction, you can always pretend that there's like an imaginary 1 right there. And same thing there. Imagine there's a 1. All right. Autumn, what do you get when you flip 1?
1.
1. It stays the same. Right. Mateo, how about if I flip 0 over 1? What does that turn into?
Would that be undefined?
That would be undefined. Very good. When you flip 0 over 1, it becomes 1 over 0. We just said that's undefined. So when you flip 0, you get undefined. When you flip undefined, what do you get? Yep.
1.
Well, undefined is 0 over 1.
Is 0.
I'm sorry, undefined is 1 over 0. So when you flip it, it becomes 0. Flip 0, you get undefined. Flip undefined, you get 0. And those are our 6 trig functions for 90. Yeah, questions on those? All right, this one I'm going to let you guys try. This time it's only asking for 3. The sine, the cosine, and the tangent. But what's different about this? Even different from the last problem. Vivian?
This is radian.
It's in radians. Okay, so it's probably going to be a lot easier to, you just send back in, Bill.
I'm going home. The nurse told me to just grab my stuff and go back down.
Okay. Yep, that's fine.
So, do I need to sign back in and then sign back out, or?
Nah. So yeah, we're in radians. If you can work with radians, fine. If you can visualize where 3 pi is on the circle, you're good. If you can't, you might want to change it to degrees. How do you change radians to degrees? What do we have to multiply by to do that? Jess?
180 degrees over pi.
180 over pi. And when I do that, Katrina, what happens here? Maybe if you want to think about it like that. What could I do before I multiply those together?
Get rid of the pi.
Yep, we can get rid of the pi's. And now I have 3 times 180, which is how much? Yeah, Vivian?
40.
540. So now I'm trying to find the coordinates for 540 degrees. So it's in degrees. I like that better, but I still don't like 540. And we talked about this earlier. How come I don't like 540? Yep.
It's above 360.
It's above 360, okay? We like to keep it under 360. So now, what can I do that won't mess up the problem, but it will make the angle smaller?
Subtract it by 360.
I can subtract 360. So if you minus 360 from that, you're going to get 180. So So now you've converted something that was in radians, that was kind of hard to think about, to a coordinate that hopefully you can visualize where that would be on this circle. Write down first what you think the coordinate is for 180, and then try to fill in the sine, the cosine, and the tangent. Let's start with our coordinate. Anyone think they have a coordinate for 180? Basic?
-1, 0.
Yes, -1, 0. Now, we just fill it in. How about, Ava, what's my sine gonna be? What's my formula for sine again?
Isn't it sine equals y?
Yes, you're correct. I'm sorry. It is 0. You are right. I was. Frank, can you just shut that for me? You just shut the so yes, 0. You are correct. Cosine, right? That is my x value. In this case, -1. And tangent, y divided by x. What is my tangent? Pete?
0?
It is 0, yes. 0 divided by -1. That is not undefined. It's only when 0 is in the bottom. Perfect. Any question at all? Finish up with this one. So, find the 6 trig functions of 11 pi over 2. Let's just do the first 3. So find the 3 trig functions of 11 pi over 2. Okay, so what am I missing? Not asking how to get what I'm missing. I just want to know what I'm missing. James?
The degrees or the coordinates.
I'm missing the coordinate. That's what I need. However you can get that coordinate, that's what you got to figure out. James said, well, we don't have it in degrees, so that might be something we want to do. Let's change it to degrees. Pi's cancel out. 2 goes into 180 how many times? 90. And what's 11 times 90? 990. Okay, so at least I got something in degrees. I'm a little more familiar with that, so that's good. Still not a great angle to work with though. What can we do to make this angle even easier to think about? Yep, Eva? So we're going to take 990 minus 360. Okay, so I got 630. What do I do now? Yep.
You can subtract it again, you get 270.
Do it again. 270. Okay, stop. Because now we have an angle between 0 and 360. What is my coordinate for 270? Think about the circle. Imagine where 270 is. And then try to write down your coordinate. Raymond?
0, -1.
0, -1. So this time, my sine is my y value. Cosine is my x. And tangent is y divided by x. What do you get when you do y divided by x here? Yep.
Undefined.
Undefined. Good. We didn't have anybody mess any of those up. That's really good. A lot of people mix up undefined and 0. Okay. So that's the first part of unit circle trig. You guys got about 12 or 13 minutes. You have a little time to start that if you want to. There's other stuff you want to work on for another class too, that's fine. you want to talk to me, ask me some questions, that's fine too. Okay, but the homework is 11 to 27, odd, and 22. Okay, just a heads up for tomorrow night's homework, it will be a worksheet, but it's on Schoology. So make sure you have access to that, but I'll show it to you tomorrow.